In the previous lesson, we talked about finding inverse trig functions. So for example, something like the inverse sine of 1/2 is 30 degrees or pi over 6. So that's what was going on in the previous lesson. So the thing you need to remember is that you are working backwards. I'm telling you that the sine of 30 degrees is 1/2. So doing the inverse, sine of 30 degrees is 1/2. Okay, so what if the value that you're given for the sine or the cosine or whatever it is, what if it's not 1/2? What if it's 5/13? What if it's 3/5? So we're going to look at that in today's lesson. First thing that's going to be super helpful for you is if you know your Pythagorean triples. So Pythagorean triple, 3, 4, 5. Pythagorean triple, 6, 8, 10. Notice that 6, 8, 10 is just double of 3, 4, 5. So it's not a unique triple. I call it a modified triple. Unique triples, 3, 4, 5. 5, 12, 13. 7, 24, 25. 8, 15, 17. There's also 9, 40, 41. Rarely do you see that used in problems. These right here are the most common Pythagorean triples. Those are the most common Pythagorean triples. So we're going to continue to work backwards, but it's going to become a little bit more complex. Okay, so let's say that I ask you for the cosine of the arctangent of 4/3. The cosine of the arctangent of 4/3. Okay, this arctangent of 4/3, that's theta. This is some angle whose tangent is 4/3. I don't recognize 4/3. 4/3 is not something that I use on the unit circle. I recognize root 3 over 3. I recognize 1/2. I recognize 2 root 2, etc. So 4/3, I can find out though 4/3. I can draw it. So whenever you see a unique value for the tangent, the cotangent, etc., your best bet is to draw a triangle and then label your sides. Well, what does that mean? Okay, so the inverse tangent is positive in quadrant 1. If you are given a positive value for sine, cosine, tangent, cosecant, secant, cotangent, if you are given a positive value, it is always, always, always in quadrant 1. Okay, so some angle. I don't know what its value is, the angle measure is. I don't care what the angle measure is. I don't need to know. What I do need to know is how to label the sides. So if the tangent, some angle whose tangent is 4/3, here's the tangent, label your sides 4 and 3. Which ones? So tangent is opposite over adjacent. Go back to your SOHCAHTOA days. So tangent is opposite over adjacent. So for this particular angle theta, again, I don't know what its value is. I don't care what its value is. Opposite is 4. Adjacent is 3. Okay, so again, SOHCAHTOA, opposite over adjacent for tangent, opposite for adjacent 3. And now is where you can use your Pythagorean triples. So that's what I started with, I don't know, a few minutes ago. So if one leg is 3 and one leg is 4, the hypotenuse must be 5. And you don't have to show any work for that. It's going to help you immensely if you just know 3, 4, 5, 5, 12, 13, blah, blah, blah. So this got erased. I want to know now the cosine of this angle. Well, again, going back to SOHCAHTOA, you know the cosine. The cosine of this angle is 3/5. Done, move on. So let's do another one with a negative value. Be patient, the board is small, so I need to erase a lot. Okay, so let's say you have something like the cosecant of the inverse tangent of, how about negative 13, nope, no, negative 12. Negative 12/5. Okay, so inverse tangent of negative 12/5. That's just some angle whose tangent is negative 12/5. This is some angle, some theta. I always use theta. Some books use x, but you should get used to theta. Some theta whose tangent is negative 12/5. Okay, so from yesterday, you need to know that inverse tangent is negative in quadrant 4. Inverse tangent is negative in quadrant 4. So if you're unsure of that, go back to the previous lesson or come to office hours and I'd be happy to help you. So tangent, negative 12/5. So just from the previous example, tangent is opposite over adjacent. Tangent is opposite over adjacent. So the opposite is negative 12. The adjacent is 5. And then it's Pythagorean triple, 5, 12, 13. You don't need to show any work. I mean, I'm not going to see all your work anyway, but if you know your triples, label your sides, you're good to go. So now I want to find the cosecant of this angle. It's in fourth quadrant. That's all that matters. I don't know its measure. I don't need to know its measure. So cosecant is the reciprocal of sine. So the cosecant is hypotenuse over opposite from SOHCAHTOA. Alrighty, so the hypotenuse is 13. The opposite is negative 12. So the answer to this question is negative 13/12. Nowhere along the line did I find theta. There's no pi's here, there's no degrees, whatever. It's not necessary. What's necessary is where does the triangle get drawn. So let's do another one that's a little bit funkier. Okay. Let's do the cosine of the inverse cosine. No, that's not right. Oh, yeah, it is. Sorry. The cosine of the inverse cosine of 30 degrees. Huh. This is weird. This is supposed to be, when I was doing it previous at 2 examples, this is supposed to be some angle whose cosine is 30 degrees. How does that match up? I want to know the cosine of whatever this value is. So if I want to find the cosine of the inverse cosine of 30 degrees, okay. The operations reduce out. I don't want to say that C word. If I want to find the cosine of the inverse cosine, it's just whatever answer is here. So let's say I want to find Let me do a better example. Let's say I want to find okay, I'm not gonna lie, I messed this up. The inverse should be here. Sorry. I don't want to stop the whole video and start over. I made a mistake. I made a mistake. I had the inverse in the wrong place. Sorry, this is the correct way to go. Cosine of 30 degrees. So the cosine of 30 degrees, I believe, is root 3 over 2. This right here is root 3 over 2. Now I want to find the inverse cosine of root 3 over 2, which is just 30 degrees. I worked inside. I found the cosine of 30 degrees was root 3 over 2. And then I did the inverse cosine of root 3 over 2. Well, that's just 30 degrees. They're opposite operations. That's what I wanted to say. Or they're inverse operations. They're inverse operations. So let's do one more. Okay. Let's do the tangent of the arc secant, tangent of the arc secant of 0. The tangent of the arc secant of 0. Okay, arc secant. Arc secant is just a fancy way of saying the inverse secant of 0. Same thing. This is some angle whose secant is 0. Okay, so in the previous two examples, I drew triangles. How do I draw a triangle that has a secant of 0? So think about that. Push pause. Think about it. If you're going to have a secant of 0, you have to be on an axis. If my secant is 0, that means my cosine has to be 1. And here's how I got that. So secant 1 over the cosine, yeah? The secant is 1 over the cosine. So in this case, if I did 1 over the secant is the cosine, and I want my cosine, I want my secant to be 0, how on earth does that work? Okay, so cosine is, did you see that this can't work? You know, it can never divide by 0. Dividing by 0 in your entire math life is never allowed. So let's look at the cosines. Those are all my cosines. Agreed? X is cosine. So, secant 1 over 1 would be 1 over, secant is 1 over the cosine, so 1 over 1 would be 1. So can't be here. Cosine is 0. If the cosine is 0, then the secant is undefined. Can't be here. If the cosine is -1, then the secant would be -1. How on earth am I going to get a secant of 0? How am I going to get a secant of 0? Remember, this is some angle whose secant is 0. There is nowhere where the secant is 0. There's nowhere where the secant is 0. So this is undefined. And there you have it. Come to office hours if you need, or send me or post questions on the stream.